Welcome to EMI-BRAIN, your one-stop channel for tutorials that make learning simple, sharp, and successful.
Alright, so let's look at sets. Who can tell me what do you understand by the word sets or sets? Oh, yeah, put this down, right? A set is a collection of well-defined objects. A set is a collection of well-defined objects. If it's not a collection, it's not well-defined, it's not called what? A set. Are you getting the gist? Like, for example, we are all set of what? EMI-BRAIN students. So it's well-defined that every element in EMI-BRAIN are what? A collection of what? Objects that forms what? EMI-BRAIN. Are you following now? So when you hear the word set, what comes to your mind is what? A collection of well-defined objects. Now the symbol for representing sets is this. So the symbol for set is what? This symbol here. Are you following? Oh yeah, put this down. Put this down. Let's look at types of sets. Types of what? Sets. What is the first one? An empty set. Please write. An empty set is a set that has no elements. A set without any element is called what? An empty set. A set without any element or without no element is called what? An empty set. So the symbol for empty set is either this, just a set without what? Any element, or this. When you see a symbol like this represents what? An empty set. It's called null. Also called what? Null what? Set. A null what? Set. Another name for empty is what? Null. Meaning when a set has no elements, when a set contains no element, it's called what? A null set, or what? An empty set. Number two is what we call universal set. Universal what? Set. Please write. A universal set is a set that houses every other subset. A universal set is a set that houses or that contains every other what? Subsets. Is a set that contains or that houses every other subset. The symbol for universal sets is simply this. Alright? Okay. The symbol for that is this. For instance, or for example, general set equals a set of natural numbers. Set of what? Natural what? Numbers. Natural numbers. Are you following? Set of natural what? Numbers. Meaning u equals what? What are natural numbers? 1, abi? 2, 3, 4, 5, dot, dot, dot. Are you following? Meaning to 100, 1 million. Now when you see the word dot, 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 that means what? It's an infinite what? Set, right? Meaning they are uncountable. There are other numbers that precede what? 5. Are you there? So when you hear the word general or universal set, these are sets that houses or that contain every other what? Subset. For example, Nigeria is a general set. Hope you are aware. The general set, because in Nigeria we have other subsets. We have Imo State, we have Anambra, we have, you get the gist now. So all those states represent what? Subsets. And what is a subset? Subsets are part of what? General sets. Are you getting the gist here? Imo State is part of what? Nigeria. So Imo State is a subset of what? Of Nigeria. Okay? Alright. The next one, let's look at. Are you guys following? Okay. The next. Finite. Finite what? Sets. What are finite sets? Set with what? Limited elements. Set with limited what? Elements. A good example of final sets, e.g., if set A equals 1, 2, and what? And 3. This means what? A finite was set. But if I have this, I have 1, 2, 3, dot, dot, dot. Can we call this a finite set? No, this becomes what? Infinite. Because there are other numbers there, right? That shows that the number that precede what? 3. Which are what? 4, 5, 6, 7, 8. Down to what? Infinity. So if numbers can be counted, they are what? Finite. So the fourth will not be what? Infinite. What will be infinite? What's infinite set? That are what? They have unlimited what? Elements. These are sets that have unlimited what? Elements. Am I communicating? Good. Set that has unlimited elements. So you can use this as what? An example. Just write example A equals to this. 1, 2, 3, dot, dot, dot. Are you there? Okay, the next one, number 5. Let's look at subsets. Subset and proper what? Proper subset. Now let's differentiate these two. Although they are the same, you have to take note that, right, all proper subsets are also called subsets. Note that, right, I will explain. All proper subsets are also called what? Subsets. All proper subsets are also called subsets. Now what is a subset? Subset is a set that is part of another set. A subset is a set that is part of what? Another what? Set. A subset is a set that is part of what? Another set. Are you there? Now let me give an example so you can understand that. Please pay attention. This part of sets can be confusing sometimes. Now the word subset. What is the symbol for subset? See bar, then there's what here? A line, right? Then we have what here? Proper what? Proper what? Subset. Which is what? Just your normal what? Curve C. Are you getting this here? In mathematics, this sign means what? Sometimes means an equal sign, right? If I have this greater than, this means what? Greater than, right? If I have this here, what does it mean? Or equal to. Are you getting this here? So if I have this means a subset. Then we have what we call what here? An equal sign. Are you there? Now watch. If for example now I'm saying that A is equals to what? 1, 2, and what? And 3, right? Then B is 1, 2, 3, 4, and what? 5. Now, what do we say is a subset? Subset means part of what? Another set, Abi. Now, is A a subset of B? Yes. Because all the elements in A are what? In B. But although A is not equal to what? B. Are you getting this here? So here we are saying that A is a subset of what? Of B. So when you do what? Subset. Subset simply means when a particular set is part of what? Another what? Set. But there are two conditions under what? Subset. The condition is that your A is either equal to what? B, or A is not equal to what? B. Is it making sense? Let me show you why. If I should remove this here, it simply means this is not satisfying just one word condition. That means that A is not equal to what? B, because there's no equal sign. Am I communicating now? But if I have an equal sign here, that means that subset satisfies what? Two conditions. What the first condition? A is equals to what? B, or A not equals to B. Are you getting it? So for this, a good example, watch. If A, let's say A is 2, 4, and 6, huh? Then let's say B is what? Let me rearrange it. 4, 2, and what? Let me say give the same thing. 2, 4, and what? And 6. What does it mean? It simply means that, what do you notice here? A is what? Equals to B. Are you getting it here? So that means that this expression simply means A is a subset of what? B. But the condition here is that our A is equals to what? B. Abi? Are you getting it here? Now, what I'm trying to say is this. If I have two sets, let's say set A and what? Set B. If set A is not equal to what? Set B, and all the elements in A are also in what? In B. That means A is a what? Subset of what? Of B. Are you getting the gist? Now, for this now, when you add the word proper subset, that also implies that if A is equals to what? 1, 2, 3, and B is what? This. That also implies that A is also what? A proper subset of what? Of B. What the condition here? When you have only C means what? A is not equal to what? B. So the word proper subset and the word subset, they are almost the same thing. That's why I say that in the first one I said all proper subsets are what? Are what? Subsets. Is it a note? All what? Proper what? Subset are what? Are subsets. So when you hear the word proper subset, it's same as what? The word subset. Are you getting the gist here? The only time you are required to bring out this sign, most of the time, is when the value of A and B are what? The same. Now let me ask again. Let me ask a question. What are the two conditions for subsets? A equals to B, A is not equals to B. The A equals to B, where is that there coming from? This line B, not equals to means what? This, right? Is that not? Then for proper subset, is there any equal sign here? Yeah? So that means for this, I can say that A is a subset of B, Abi, and A is also what? A proper what? Subset of B. Do you get the concept now? Because they're saying that proper subset are also called what? Subsets. Do you get the gist? All proper subsets are subsets. Because in a proper subset, we can generate this from what? Subsets. Okay. Then there's also called super sets. Right? Super sets. Yes. Which one? A equals to B or A is not equals to B. This is for subsets. Do you get the gist? What's the question? Yes, for these two conditions, the conditions, please write. The condition for subset is that A sometimes is equals to B or A is not equals to what? To B. And the idea of these two conditions is from this line here. If I remove this simply means what? A must not be equals to what? B. Or A is not equals to B. Do you understand the concept here? And this is what? For what? A proper what? Subset. So if I have this becomes what? Yeah, a subset. So we have both equals to and not what? Equals to. Only C means what? Not equal. Are you getting the gist? So when you hear the word proper subset, it simply means that the two sets are not what? Equal. It's called proper subset. But proper subset is also called what? Subset. That's where the confusion is, right? Yes, sir. Only one condition. Only one condition. Only one condition. Which is A is not equal to what? B. But every element in A must be contained in what? In B. Eh? Okay. Now, supersets. Superset. The next one. Number 6. Superset. I won't talk much on this. I'll just give you an illustration. Look at this. Listen. Right. Put this down. Let me give you something. Right. If A superset and sorry and proper what? Super what? Sets. Listen. A is the what? Subset of what? Of B. That implies that B is a superset of what? Of A. Is that clear? If A is a subset of what? If A is a subset of what? B, that implies that B is a superset of what? Of A. The symbol for superset is this. Please take notes. This symbol is for what? Subset. Subset means C, B. When you reverse that C, this will become what? A super what set. Is that clear, somebody? So for this now, look at this. If my A is 2, 4, 6, so let's say if A is what? 1, 2, 3, right? And B is what? 1, 2, 3, 4, 5. That implies that A is what? A subset of what? Of B. And that implies B is a what? Super what? Set of what? Of A. Is that clear? Eh? You didn't get it. But we agree that A is what? A subset of what? Of B, B? Because every element in what? In A are what? And B. Why do we say B is a superset? Because B contains every element in what? In A. It becomes the superset of what? Of A. Do you understand the gist now? So B becomes what? A superset of what? Of A. Now look at this now. You know, if A is what? 2, 4, 6. And B is what? 2, 4, 6, right? We agree that A is what? A is what? Of B. Because why? A is equals to B. That also implies what? You can tell me. That B is a what? Super what? Set of what? A. Because B contains every element in what? In A. Is that clear? Now, likewise under proper superset or proper, yes, superset. If A is a proper subset of what? Of B, that implies what? That B is a what? Proper what? Superset of what? Of A. Please write it down. If A is a proper subset, if A is a proper subset, if A is a proper subset, if A is a proper subset of what? Of B, what does that imply? That B is a what? Proper super what? Set of what? Of A. Okay. The next one, another type of sets. Number 7, singleton. Single what? Singleton. A singleton is a set. Singleton on the board. A singleton is a set that contains only one element. A singleton is a set that contains what? Only one what? Element. A singleton is a set that contains only one element. A good example. If A is a set of just an element what? 3. Okay? This implies that A is a what? Is a what? Singleton. Singleton means a set that has just one what? Element. Are you there? It's called what? A single. The other one, let's look at disjoint sets. And that type of set. Number 8, disjoint. Disjoint sets. Are you following? Two sets are said to be disjoint. Two sets are said to be disjoint if their intersection gives an empty set. Two sets are said to be disjoint. Are said to be disjoint if their intersection gives an empty set. If their intersection gives what? An empty set. What is the meaning of intersection? Although I've not entered that part. What intersection? What is common between two sets, right? Right? Okay. So if I have, for example, given that A equals odd number 1, 3, 5, 7, and 9. If B is a set of all even numbers 2, 4, 6, 8. Now let me stop at 10. Are you there? What is A intersection B? Is what? It's none. It's an empty because there's no common what? Element, right? So this implies that set A, right? And what? And set B are called what? Are called what? Disjoint set. Thank you. They are called disjoint sets because their intersection gives what? An empty set. Let's look at set operations. Subheading, set what? Operations. Set operations. Set operations. The first set operation, correct me? Number 1, union of a set. Union of a set is the combination of two or more sets without repeating an element. As a union of a set is the combination of what? Two or more what? Subset, right? Without repeating what? An element. For example, the symbol for union is what? Is U, right? Just this form of U. Example, if we are given that set A is 1, 2, 3, 4, and 5, and set B is 2, 3, 4, 6, 7, 9, and 10. And we also find, let me give another set C. Set C is a set of even numbers 8, 10, 12, and 14. Let me stop here. And we also find the following. Number 1, find A union B. Number 2, find A union C. Number 3, find B union what? C. Huh? Now let's go. What is our A union B? Union means we are going to combine, right? Without repeating elements. In a set, we don't repeat what? Elements in a set. What's the first one here? 1, 2, right? Are you following? 2 appear again. Will I repeat again? No. So I'll pick 1, 2, 3, 4, 5. Let's go. 1, 2, 3, 4, 5. Is that 6? 7. There's 8, right? Okay, just A and B. Thank you. 7, 9, and what? 10. Thank you. Okay, what about A union C? Between A and C. Let's go. 1, 2, 3, 4, 5, 6, 8, 10, 12, and what? 14. What about B union C? Let's go. 2, 3, 4, 6, 7, 8, 10, 12, okay? And what? 14. Please put this down. Put this down. Union means combining, right? Without repeating what? Elements. Alright, so the next one. If you have any question, you can ask a question. All these parts of sets are very simple. Yes. The combination. Okay. For A and B, I want to combine this A and B. It means I'll pick all the numbers in word A and what's in B, but without repeating any. We have 1 and B. Next is what? 2. What the next? 3. Although we have 2, 2, I won't repeat 2, 2. I'll just pick 1. You understand? So we have 1, 2, 3, 4, 5. I can even pick 1, 2, 3, 4, 5. Followed by what? 6, 7, 9, and what? And 10. Then for A union C, what the least number between A and C is 1. Followed by what? 2. So I bring that 1, 2, 3, 4, 5. Then now start with what? 6, 8, 10, 12, and what? 14. Is that not? Then for B union C, between this and this, let's check. We don't have 1 in B and C. So the least here is what? Is 2. So 2, 3, 4, right? 6, 7, 8, 9, 10, 12, and what? 14. Just like that. Is that okay now? Okay. The next one, number 2, intersection. Intersection of sets. Two sets are said to be intersected. Two sets are said to be intersected. Two sets are said to be intersected with each other if they have a common what? Element. Two sets. No. Disjoint is if they don't have a common element. That means A and B are what? Disjoint. But if they have a common element, it's not same as disjoint. Are you there? So for example now, if I have set A equals 2, 4, 6, 8, and 10. Set B, we have 1, 2, 3, 4, 6, and 9. And we also find A intersection B. The symbol for intersection is what? Is N, abi? Now, between A and B, what is common? What can you see in A? Also in what? 2, 4, 6. Is that 8? 2, 4, and what? 6, right? Okay. 2, 4, and what? 6. These are the common elements between A and what? And B. Number 3. Oh yeah, put this down. Yeah, money. Set difference between A and B. Set difference between A and B. Set difference between A and B. That is A minus B or A difference B. A difference what? B. Hi there. Includes. This includes all the elements. This includes all the elements that are in A but not in what? In B. Set difference between A and B. That is A minus what? B, right? Includes what? All the elements that are found where? In A, but not in what? In B. Have you captured that? This includes all the elements that are found in A, but not in what? In B. Are you there? You have to note that A difference B is equivalent to what? A difference B in this format. This means division, right? When you see something like this, A divided by B, that means A difference B. It's the same thing with it. It means element in A but not in what? In B. Element in A but not in what? In B. And it's also same as what? A intersection what? B what? Prime. B what? Prime. B complement. For example, let me give an example. E.g., if we are given that set A is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we are given that B is a set of even numbers 2, 4, 6, 8, and what? And 10. Then we have to find A difference what? B. What is A difference B? The elements that are found in what? In A, but not in what? In B. Which are what? 1, 5, 1 what? 3, 5, 7, 9, right? Is that 10 again? That's okay. Only this, right? Good. 1, 3, 5, 7, and what? And 9. What about if you have to find B difference A? What does that imply? Elements in B but not in what? In A. Which are what? What are the elements you can find in A? Sorry, in B. Now not in what? In A. An empty set, right? Good. It's an empty set. Hope you understand the concept now. Good. We have to also note that B difference A is same as what? B slash what? A, right? Also same as what? B intersection what? A complement. Please take note of this. Right now we go into analytical proofs in sets. I will explain all of this. Okay. What about this question here? If A is given as this and B is this, what is A difference B? And what is B difference A? Uh, the element that are in A, not in what? B are what? 8. Eh? Element in what? A, not in B are what? Uh-huh. What about this? Element in what? B, not in A. 1, 3, 9. Thank you. Hope it's clear, right? Let's look at what we call complements. Complements. This is number what? Number what is this? Number 4. Complements of what? A set. Complement of a set is almost same with set what? Difference. Let me give you this, right? Put this on your notes. Complement of set A. Complement of set A, capital A. Complement of set what? A includes all the elements that are found in the general set. Includes all the elements that are found in the general what? Set. But not in what? Set A. This includes all the elements that are found in the general set, but not found in what? Set what? Set A. This morning I explained what is general set, Abi. What general set? A set that contains other what? Subsets. Are you following now? Okay. That is, what I'm saying here is that general set minus what? A, is equal to what? Somebody? A what? A what, yeah? A complement or A prime. Most of the time they will use the what? A raised by C. When you see this in sets, they are the same. This means what? A complement. This means what? A prime. They're all the same. A prime. They're all the same meaning. Are you there? Okay. Now, an example. E.g., if we are given that general set is 1, 2, 3, 4, 5, dot, dot, dot to 20, and we are given that A equals 2, 4, 6, 8, 9, 10, 12, 13, and B is 1, 3, 5, 6, 14, 15, 16, 17. Let me add 18 here. Then I have 19 and what? 20. Then we have to find A complement. Number 1. Number 2, find B complement. What is A complement? Elements that are found in the general set, but not in what? In A. What and what? Tell me. 1, 3, 5, 7. Is it 11? 14, 15, 16, 17, 19, 20. Hope you are aware that between 5 and 20, there are other numbers here. Okay. So what about this? What about B complement? 2, 4, 7, 8, 9, 10, 11, 12, 13. There's 14, 15, 16, 17. What next? 18. That is all. Thank you. Are you getting the gist here? Okay, let's look at number 5. Cardinality first. Cardinality of a set. Put this on. Cardinality of a set refers to the number of elements in a given set. This refers to the number of elements in a given what? Set. Cardinality of set A is represented as NA. So for instance, if we are given that set A equals 2, 4, 6, 8, 9, 10, what is the number of elements in A? NA means what? Cardinality, right? Okay, you can see find the cardinality of what? Of A. Now, what do we do here? Cardinality of A means what? NA, right? What's the answer here? 1, 2, 3, 4, 5, 6. This is simple, right? Okay. What if we are given this? Number 6. If we are given that set B equals 1, 2, 2, 3, 4, 4, 6, and 8. And we have to find the number of elements in what? In B. In what? In B. What's the answer here? 8. Okay, wait again. 6. Which one is the correct one? In a set, we don't repeat an element in a set. When two elements appears, when an element appears twice, take them as what? As 1. So let's count 1, 2, 3, 4, 5, and 6. Are you there? So what's the answer here? 6. What about this? If we are given that, let's say set A equals to a null set in a bracket in a set, what is our NA? 1. Why is it 1? Why not 0? Why not empty? Good, because whenever a null set is inside a set bracket, it becomes what? An element of what? Of that set. Are you following? This is called what? What is the answer here? 1. Okay. Correct me? Let me give one more example. Oh yeah. If we are given that set A equals, I have 2, 4, then I have 3, 5. What is our NA? 4, 3. Which one? Why is it 3? These two sets here, this set here is taken as what? As what? 1. You have to note that after writing this, note that a set inside a given set is an element of that what? Set. A set found inside a given set represents what? An element of what? That set represents. Note that a set found inside a given set is an element of that set. So that means that sets 3 and 5, they are taken as what? 1. Are you following? Now let's solve this workbook here so we can be on the same page. Put this on. Given a set, I will solve all the problem on that set here. Given a set, Can I help me here? Given the sets U equals X. Okay, I didn't explain sets notation, but let me just use this to explain. F is such that 0 is less than or equals to what? X less than or equals to what? 20. And we are told that set A, the elements in set A, we have 1, 3, 5, 6, 10, 16, 18, and 20. And 20. Then set B, 1, 2, 4, 5, 7, 9, and 11. We're now told that where A is a subset of U and B is a subset of U, we have to obtain number 1, A intersection B. Number 2, A difference B. Number 3, A complement union B complement. Number 4, universal set difference A complement union B complement. Now we are given the sets. The general set is that F is such that X, so 0 is less than or equals to what? X less than or equals to what? 20. And A is also given, right? And B is also what? Given. Now this simply means that there are 2 ways using describing sets. Using what? Describing what? So you can put it down somewhere in your notes. There are 2 ways using describing sets. Number 1, by listing. By what? Listing all the elements. Are you following? 1, by what? By listing all the elements. All the what? Elements. Number 2, by using set what? Set notation. Set what? Notation. Are you getting this here? Look at this. A, this is by listing. Listing means we list out all the elements in what? In a given set. 1, 2, 3, 4, 5. Maybe A is a set of all even numbers. Are you there? Or A is a set of all prime numbers, or all odd what? Numbers, or natural what? Number. You list them out. That's by listing. Sometimes they will put those elements of a given set using a code called what? Set words. Notation. Like this now we have here. F is such that 0 is less than or equals to what? X less than or equals to what? 20. Then what you have to do is to interpret this set word notation. I have to list out all the elements here. Are you getting the gist now? If you are given a set in form of set notation, what do you do first? List out all the elements of that given word set. Then when you list them out, you can be able to solve the rest. But we are told that, yes, there. No, I'm coming. I will explain that. I'm coming. So we are not told that where A is a what? This symbol means what? Subset of what? Of U. Meaning that every element in what? In A are what? In B. This means what? B is a what? Meaning every element in what? Do you get the gist here? What condition is this? You know we have 2 conditions for subset. Who can tell me? Either A equals to what? B, or A is not equal to what? B. Right? Those are means the first class. Please take the note from them. Or you can go back to my YouTube channel and watch to differentiate between subset and what? And proper what? Subset. Now we can bring out all the elements here. Listen please. If X is such that 0 is less than or equal to X. If 0 is less than or equal to what? X. What does this imply? That X is greater than or equal to what? 0. Hope you are aware. That means that you now ask yourself, what are the numbers greater than what? 0? And also equals to what? 0. Because we have an equal sign here. It means I will start from where? 0. What the next one? 1, 2, 3. But if there is no equal sign here, that means I will start from what? 1. It means I have to exceed this 0, right? And start from 1. Are you getting it, here? Are you getting it? Okay, look at. I want to interpret this. I want to bring out all the values of what x. Here we are told that 0 is less than. This sign is what? Less than or equals to x, right? The reverse of this means what? X is greater than what? 0. If 2 is less than 3, that means 3 is greater than what? 2. If 0 is less than or equals to x, that means what? X is what? Greater than or equals to what? 0. So this is it here. 0 is less than or equals to x. This also implies what? That x is what? Greater than or equals to what? 0. You now ask yourself, what are the numbers greater than what? 0. Also equals to 0. Because we have an equal sign here. Are you getting the gist here? Since this equal sign is, that means 0 is part of those numbers. Followed by what? 1. Number greater than 0 are what? 1, 2, 3, 4, 5. Abi? Is it not? So since I have an equal sign here, that means my set, general set becomes what? A set of what? Numbers starting from 0, right? What the next one? 1. What the next one? 2. What the next one? 3. What the next one? 4. But mind you, we are told that that same x is what? Less than or equals to what? 20. Meaning I will start from 0 and end where? At 20. Is that clear? But if I don't have an equal sign here, what will happen? I will start from 0 and end where? 19. So we have equal sign here. So let's go. Let's bring them out. We have 5, right? We have a 6. Dot, dot, dot. Down to what? Somebody? 20. Meaning we have other numbers, right? Already we are getting our A. No need of repeating A again. Let me see repeat A. What's our A? What's the value of A? Give me the value there. 1, 3, 5, 6, 10, 16, 18, and 20. What about B? 1, 2, 4, 5, 7, 9, 11. Okay. The first question says what? A intersection B. By now we all know what is intersection, meaning between A and B, what is common? I want to explain this now. Whereas what they are saying here is that A is what? A subset of what? General. That means every element in what? In A are in what? This. Do you get? That means A. A is part of universal set. This means what? B is what? Part of what? Universal set. Are you getting this here? Look at them. What is the reverse of this? If A is a subset of general set, that means U is what? A superset of what? A. What about this? Thank you. Now, intersection between A and B, what is common? Thank you. I hope you know how we go 1 and 5. You take A and take B. What are the common elements there? Just 1 and what? 5. Number 2 is what? Number 2 is what? A difference B, right? This symbol means what? When you see a slant line separating two sets, it simply means what? Difference. We call it set difference. And we stated that A difference B is same as what? A minus what? B. Also same as what? A intersection what? B what? Prime. Or B complements. Are you following? If I have B difference A, that means what again? B minus what? A. Also same as what? B intersection what? A prime or A complements. Are you getting the gist? Now, can we do the same thing? Can we solve this here? And what is the meaning of this difference? It means what are the elements that are found in what? In A, but not in what? In B. Element found in A, not in B. Is what? 3, 3, 6, 10, 16, 18, and what? 20. What's the next one, yeah? Number 3 is A complement. You know what? B complement. There's a law of sets, but I've not gotten there step by step, called the De Morgan's law of sets. De Morgan's law of sets says that A complement union what? B complement is same as what? A intersection what? B. All what? Somebody complements. That means there are 2 ways you can solve this. You can either bring out what first? A complement, right? Or bring out what? B complement, then get their union. Is that not? Or we have only solved what? A intersection B, right? This simply means what? Elements that are found in the general set, right? But not in what? A intersection B. That means all the elements in this minus what? 1 and what? 5. Which are what? 0, 2, 3, 4, 6, down to what? 20. Am I communicating? So which one should we do? Should we use this or this? This one, Abi? We also try the other one. Okay. Union, you still get the same thing. You should understand both of them because very soon I will teach us the laws of sets. Can I clean this part? What of this part? I want to solve. Okay. Now watch. So we are asked to find this, right? So what do we do first? For the third one, A complement, union what? Union B complement. So the first is to find what? Thank you. A what? Complement. And what's A complement? These are sets of all the elements in the general set, right? That are not found in what? In A. This is same as general set difference what? A, right? Now let's go. What do you have here? 0. Elements that are found in the general set but not found in A are what? Give me the value. 2. That's all right. Now let's find B complement. What's B complement? Element found in general set but not in what? In B. What are they? 0, 8, 10. Now the next is to find what? Therefore, A complement union what? B complement. By now we know what is union, right? Meaning combining both this and this without repeating any elements. Can we combine now? What the least number here? 0. So let's go 0. What again? 2. What again? 3. What again? 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19, and what? 20. Right? Okay. So please put this down. Then if I'm to use this to solve, can we check this together? If it's true. Is it correct? Huh? I capture this first. What is A intersection B here? 1 and 5. This simply means what? Those elements that are found where? In the general set, but not in what? A intersection B. Meaning all the elements in what? General set minus what? 1 and 5. Which are what? The same thing, right? The same thing. To me, I prefer this. I don't need to start doing all of this again. Just know the laws of sets. You can be able to tackle this. Huh? Okay. What's the next question there? Okay, union difference. Thank you. Union difference what? A complement. Union what? Union B complement. What does this imply? A complement. Union what? B complement. This simply means that those elements that are found where? In the general set, but not in this. What is the answer? 1 and 5. Am I communicating here? Now let's watch. Elements that are found in general sets. General set is what? From 0 to what? To 20, right? But not in what? Not in this. Are you there? Are you there? That means there are those elements in the general set minus what? Minus this, which is what? Somebody? 1 and 5. Is that clear, somebody? So put this down. Put this down. Put this down. Yes. Hey, let me just say, okay? Of course, there's a proof in sets that the whole of this is also equal to what? A what? Interaction what B. Exactly. This is equals to this. This expression equals to what? A interaction B. When we get to proof, you understand better. The next set operation I want us to look at now is what we call power sets. Power what? Can I me here? Please put it down. Power sets of a given set or power set of set A. Power set of set A. Power set of set A is given as the power set of set A is given as P of A equals 2 raised power what? N. Power set of set A is given as P of A equals what? 2 raised power what? N. Where N is the what? Is the cardinality. Is the what? Cardinality of what? Of a set. Please write. Power set tells us. Power set tells us or shows. Power set shows or tells us how many subsets are contained in a given set. Power set tells us or shows how many what? Subsets are what? Contained in a given set. It tells us how many subsets contained in a what? In a given set. Note that the first subset of every given set, note that the first subset of every given set is an empty set. Note that the first subset of every given set is an empty set. Is an empty set. Are you there? Let me look at an example here. If we are given that set A equals 2, 4, and what? 6, and we also find the power, the set of what? Of A. Are you following? To solve this, we have to recall the power set of A. What the formula I gave you? I gave us 2 raised power what? N. Where N is what? Cardinality of what? Of the set. Are you following? That means that recall the power set of A is 2 raised power N. Here my N equals to what? 3. Cardinality means what? Number of elements in a given set. How many elements do we have in this set? So we have 1, 2, 3. So my N is what? 3. Exactly. So that means here becomes what? Yeah? P of A equals 2 raised power what? 3. And what 2 raised power 3? 8. 8 what? Yeah? 8 subsets. That means set A has how many subsets? 8 subsets. And what do we say the first subset of every set? And 3 sets. So the next thing we need to do here is to list out all the what? Subset of what? Of A. Are you guys following? Are you confused? Who is confused there? Let me see your hand up so I can explain. Good. Please be sincere. I'm a free kind of person. If you can understand, I will explain again until you get it. From where? Is it how we got the 8? Okay, now look at this. Now we are given that A equals to what? 2, 4, 6. A is a subset itself. Now we have to find the power set of what of A. Formula says P of A, right? Equals to what? 2 raised power what? N. If I have B equals to 2, 4, 6, there will be what? P of what? B equals to 2 raised power what? N. The same formula. But N represents cardinality of the set, meaning the number of elements that are in a given set. Here we have how many elements here? We have 1, 2, 3. So that means that my N is what? 3. Formula says what? P of A, right? Equals 2 raised power what? N. Which is what? 2 raised power 3. 2 raised power 3 simply means what? It means 2 times what? 2 times what? 2. Which is what? 8. So that means I have 8 subsets. That means set A contains how many subsets? 8. And the first subset is what? An empty set. Am I communicating? Are you getting it now? Is that clear now? Eh? Is that clear now? Can I continue? Is it clear now? No. Okay. Where? Are you just coming? Okay, where? Recall. Power set formula is what? P of A. This means power set of what? Of A. Formula is what? 2 raised power what? N. N is what? 3. Okay, now we got 3. 1, 2, 3. So that means from here we have 2 raised power what? 3, Abi? 2 raised power N. 2 raised power 3. What 2 raised power 3 is 8. 2 raised power 3 means 2 times 2 times 2, which is what? 8. That means set A has how many subsets? 8 what? Subsets. And the first subset of every set is what? An empty set. Therefore, subsets of what? A are what? What the first one there? Is what? An empty. This is a symbol for empty set, right? Hope you are aware. So, comma. I will now bring out single set, which is what? Set 2. Just be watching. We have set 2, Abi. Followed by what? Yeah? Set 4. Followed by what? Yeah? Set 6. Our aim is to bring out all the 8 words subset, right? So the first is to start with the single set first, which is 2, which is what first? Empty, followed by what? 2, followed by what? 4, followed by what? 6. Now we now look at the double sets. Because we have how many elements here? 3. That means I can generate single, double, and what? Triple. Is that clear? Now for the double set, I'll pick what? 2 and what? Yeah? 4. I'll pick what again? 2 and 6. 2 and what? 6. I'll pick what again? 2 and 6. I'll pick what again? 2, 4, 6. 1, 2, 3, 4, 5, 6, 7. Then the next is what? 2, 4, and what? 6. Are you seeing it now? Is that clear? I will explain. You understand this, right? This one now, double sets. We have 2, 4. We are starting from 2. I will need to exhaust these 2 first. 2, 4, 2, 6. Are you seeing it? I'm done with that. The next is now what? 4. Which is what? 4, 6. Is that not? What the next? There's no other one again. Which is what? 2, 4, and what? And 6. So when you count, we have 1, 2, 3, 4, 5, 6, 7, 8. Now let's look at this. It constructs the subsets of the set A equals 1, 3, 5, and what? 7. The same thing. When you hear the word, sometimes they will not tell you find the power set. Once you hear the word, construct the subsets, meaning bring out all the subset of what? Of that set. And how do you do that? Is by finding first what? The power set. Are you getting it? So to solve this, can you solve this for me? Can you attempt it? Oh yeah, attempt. Let me see your work. I'm going around. So let me just repeat something. A equals this, right? Number of A is what? Is 4. We have 1, 3, 5, and 7. So the power set of A is 2 raised power n, which is 2 raised power 4. Then we have 16 subsets. So the subset of A, let's repeat again. What's the first? Empty set. Followed by what? 1. Followed by what? 3. Followed by what? 5. Followed by what? 7. Then followed by 1, 3, 1, 5, 1, 7, 3, 5, 3, 7, and what? 5, 7. Are you saying it? Now the triple set. Let's go. 1, 3, 5, 1, 3, 7, 1, 5, 7, 3, 5, 7. What again? 1, 3, 5, 7. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 subsets. Hope you have seen your mistake. Those are failed it. Have you seen your mistake? Okay. Let PE, let PE be the power set, be the power set of the set E. If E equals X, Y, and what? Z. Then we have to tabulate PE. By now you can do it, right? Can you solve that for me, all of you? Or attempt this for me, all of you. What does this imply? Tabulate PE means bring out all the subset of what? Of E. Or you do that for me. 2 minutes. Or 1 minute is enough now. Yeah, what's the answer? Just echo it for me. What the first one? Followed by what? 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 Is that okay? Okay, you got the answer, right? Or should I start again? No need. So the next question, put it down. If A is a set of positive integers, if A is the what? Set of what? Positive what? Integers. Defined as A equals X such that X squared plus X minus 6 equals to what? 0. Find the value of X satisfying the solution set. You have to take notes that we are told that if A is a what? Set of what? Positive what? You have to take notes. Defined as what? As A. A is that S is such that what? S squared plus what? S minus 6 equals to what? 0. So we have to find the value of X that satisfies what? The solution. What is solution? The positive what? Integer. Are you following now? Now what do we do here? We have to bring out the equation. We solve the equation, which is what here? S squared plus what? S minus 6 equals to what? 0. Are you following? What do we call this in mathematics? Quadratic what? Equation, right? Hope you are aware. I know we have about 3 methods using solving the quadratic what? Equation. What is the first method? Second is what? Substitution method? No. What is the first method? By factorization, right? Number 2 is by what? Also almighty. Formula method. Number 3 is what? Completing the square method. Right? Are you following? Then we can also have a graphical what? Method. Are you there? But here we can factorize this. How do we factorize? Listen, please. How many terms do we have here? 3 terms, Abi. What is the first term here? What do you have here? What do you have here? Now the principle here is this. Multiply the first term by the last term. The first term is what? S squared. What, please? S squared times what? Minus 6. That will give us what here? Minus 6 what? S squared. Are you following? The next is that you will not think of 2 numbers. 2 what? Numbers. That when you multiply them, the result will be what? Minus 6 S squared. But when you add or subtract, what will you have? S. I repeat again. Think of 2 numbers by which when you multiply them, you have what? minus 6x squared. But when you add or subtract, what we have? X. Let me help you to think. Watch. What do you have here? 6, Abby? If I have 6 here, what do you remember that can divide 6? 3, 2 can go, right? 2 years what will give us what? 3. So I can play around 2 and what? And 3. Here is 2x. Let's say I have here to be what? 6x. Minus 6x, right? Here is 2x and what? And 3x. Let's watch. What the condition here? Sorry, 6x squared. What the condition here? We have to think of two numbers that when you multiply, that will give you what? Minus 6x squared. But when you add them, you have what? X. So how do you play along this? Will it be minus 2x plus 3x? Or minus 3x plus 2x? Eh? Minus 2x and what? 3x. Or 2x and what? Minus 3x. Which one? Let's verify. Let's verify, right? Minus 2x times 3x is what? Minus 6x squared. Is that not? 2x, where is it? Minus 2x plus what? 3x is what? X. Is that making sense? Minus 2x. This is not part of it, Abi? Not part of it. Minus 2x times 3x is what? Minus 6x squared. The minus 2x plus 3x is what? X. So that means that these two numbers will replace what? Yeah, x. I believe you get what I'm doing. Are you getting it? Are you getting it? Let me show you something else. All right, let's watch this. If I have this, let's say I have x squared plus 5x plus what? 6 equals to what? 0. Let me show you. Let me use this. What do we do first? Multiply the first, Abi, and the what? Last. What do you have here? 6 what? X squared. Let's break down this. 6x squared. What can go here is 2, Abi? What do you have here? 3. Is that also? Here we have 2x and what? 3x. Now, how do we manipulate this? What is the center number here? Plus 5. Are you getting it? This? No, we say that I will think of what? Two numbers. That when you multiply, what do you have? 6x squared. But when you add or subtract, what do you have? 5x. What will it be? 2x and what? 3x. 2x times 3x is what? 6x squared. 2x plus 3x is what? 5x. Likewise this. But in this case, we now have what here? Just plus x. But still, if you multiply the first term and the last term, what do you have? 6x squared. Here we have 2x and what? 3x. We now play with this, Abi. What we do here? We chose what? Minus 2x and what? 3x. We can also say minus what? Sorry? 2x and what? Minus 3x. But this will not go. Do you know why? Minus 3x plus 2x is what? Minus x. Minus x, Abi. But here we have what here? Plus x. Although minus 3x times 2x will give us what? Minus 6x squared. But minus 3x plus 2x is not equal to what? Plus x. But in this condition here, minus 2x times 3x is what? Minus 6x squared. But minus 2x plus 3x is what? Plus x. Is that not? So that means that by factorizing this, okay, therefore, let's go. What we have? X squared plus what? The numbers are what again? Minus 2x and what? 3x. If I should add this, what do you have? X, Abi? That is, I will replace this with what? With this, right? So let's go. What we have? Minus what? 2x. Plus what? 3x. Minus what, yeah? 6 equals to what? 0. I only replace these two numbers here with this, Abi, with x. Are you there? The whole of this here is equal to what? X. So I've not altered anything, right? Between these two, what is common here? What can you see in this number, also in this number? X, Abi? So if x is common, what will remain here is x, Abi? Minus what here? 2. Or let me show you again. How do you get this? If I'm saying that x is common, just bring out the x and your bracket. Divide x squared by x. What's the remaining? 1x, abi? So you put it here. Divide minus 2x by x. What's the remaining? Minus 2, right? Minus what? Minus 2. Close the what here? The bracket. Are you following somebody? Between 3x and minus 6, what's common? Plus 3. Plus 3, right? Okay, let's plus 3. We have what here? Plus what? 3. Divide 3x by 3, what do you have? X. Divide minus 6 by 3, what do you have? Minus 2. All equals to what? 0. The gist here is that anything you have in this bracket must appear where? In the second bracket. This makes the work easy. Are you there? So therefore, x plus what? What do you have here? Plus 3 is equals to what? 0. Or I will now pick one of these, abi, which is what here? X minus 2 equals to what? 0. What is the value of x here? X is equals to what? Minus 3. Or what? X is equals to what? 2. But we are told that if A is a set of what? Positive integer, defined as what? As this. Find the value of x that satisfies what? The solution. What do you think will be the value of what? Of A? 2. Why is it 2? Because 2 is what? Positive. Are you following somebody? Therefore, since A is a what? Set of what? Positive what? Integers. Therefore, set A is equals to what? 2. Please put this down. Oh yeah, put this down. Are you ready now? Are you ready? Tabulate the sets. Tabulate the sets. Number I, set A equals x such that x is an element of natural number 3 is less than x less than what? 17. Number 2, B is that x is such that x is an integer z where x is less than or equals to what? 11. Number 3, let me add this to this first. Let me differentiate this. X is such that x element of z plus. Huh? These two are not the same. Bracket, come a comma. X is less than or equals to 11. Yes? The first one, A. B, integer. Integer. This means positive integer. This means what? Integers. This means both negative, positive, and what? 0. Are you getting the gist here? So the fourth one, okay, C is x such that x is an element of z. And here we have 3x squared plus 7x minus 6 equals to what? 0. Alright, so let's solve this together. Please pay attention. When you see the letter N represents what? Natural numbers. Are you getting with this here? Z represents what? Integer. One of Z plus, positive integer. If I have Z minus, it means what? Negative integers. Huh? Is that? If I have Z, Z means what? Integer. What is Z plus? Positive what? Integer. What is Z minus? Negative integers. Are you getting it? If I have N means what? Natural number. If I have R means what? Real numbers. Are you following? Okay, so solution. Number 1. What do you have here? A is a set of x, right? So that x is an element of what? Natural number. Here we have 3 is less than what? X. Less than 17. Now listen, the major thing you need to look at is here. You are told that 3 is less than what? X. If 3 is less than what? X. That implies that what? That X is greater than what? 3. Right? You agree with me? If 2 is less than 3, that means 3 is what? Greater than what? 2. So if I'm saying that 3 is less than X, that means X is what? Greater than what? 3. You now ask yourself, what are the number greater than what? 3? 4, followed by what? 5, followed by what? 6, followed by what? 7, followed by what? 8, 9, 10, 11, down to what? 16. Because we're not told that that same X is less than what? 17, which is what? 16. You ask yourself again, what are the number less than 17? Which are what? Which are what? 16, Abi? 15. That means I will start from where? From 4 and end where? 16. Is that clear? So that means the value of A is simply what? Let's go. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and what? 16. What if I have an equal sign here? 17. What if I have an equal sign here? I will start from what? 3. Hope you understand the concept. Okay. B parts. We are told that set. Yes. Okay, is it just now? Okay, just now included. Sorry. There is no equal sign. Hope you are aware. Okay. B is X such that X is an element of what? Of integers, right? And we are told that that same X is less than or equals to what? 11. This is very tricky. If you're not careful, you think this is a positive word, integer. Whenever there is a Z and there's no sign on it, it means what? All integers. Both negative and what? Positive. Are you getting this here? Now look at this here. If X is less than or equals to 11, that means 11 is what? Greater than what? X. How do we bring out all the elements here? What are the number less than 11? 10, 9, 8. But when I start from 10 or 11, why? Because we have what's here? An equal sign. Are you there? So from 11 to where? To negative infinity. Hope you are aware that in your number line, the center here was 0, right? Here's what? 1, 2, 3, 4, 5. Here's what? Minus 1, minus 2, minus 3, and what? Minus 4. Are you aware? Are you aware that 0 is greater than what? Minus 1. Your number tends to what? Decrease this way, right? And increase what? In this pattern. 5 is greater than 4. 4 is what? Greater than 3. 3 is greater than what? 2. 2 is greater than what? 1. 1 is greater than what? 0. That same 0 is greater than what? Minus 1. Minus 1 is greater than what? Minus 2. Are you aware? Good. That means that the value of B is simply what? Since we are starting, we are ending from where? 11, Abi. I will come to what? 11 to what? Negative, Abi. So how do we do that? I cannot keep on bringing all the negative values of this what? Number line. So I'll put what here? Dot, 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 comma. I can start with what? Minus 3. Huh? What again? Minus 2. Minus 1. 0. 1. 2, 3, 4, 5, 6, 8, 10, and what? 11. Are you following somebody? Okay, so put this out. So what's the answer? Let's go. This is I, what? Okay, let's go. Can you solve this for me? For what you have learned so far, can you attempt this? Or should I solve it? Oh yeah, solve. Let me see your work. 2 minutes. Okay, let's go. Here we are given that C is a set of X such that X is an element of what? Z. And here we have 3x squared plus what? 7x minus 6 equals to what here? 0. So what do we do here? We solve the what? We solve the what? The equation, right? So if we should solve the equation, what do we have here? We have 3x squared plus what? 7x minus 6 equals to what? 0. Let's perform that magic again. Now watch. What do we do? Multiply 3x squared, the first term, with what? The last term. 3x squared times minus 6 is what? Minus what? 18x squared. If I have 18, can 2 go in 18? What do you have there? 9. Logically, I can work with what? 9 and what? 2. Do you know why? What is 9 minus 2? 7. So that means here can be what? Minus 2x. Here's what? Plus what? 9x. Minus 2x times 9x is what? Minus 18x squared. Right? Minus 2x plus 9x is what? 7x. Is that okay? Is that okay? You didn't get it? Multiply the first term with the last term. What do you have? Minus 18x squared. Then we say you think of two numbers. When you multiply them, that will give you what? Minus 18x squared. But when you add or subtract, you must have what? 7x. Are you getting the gist here? Then we have what? Minus 18x squared. I just brought out 18. Divide 2 here. What do you have? Okay. If divide 2 in 18, what do you have here? 9, right? Is that not? Uh-huh. Please, watch. We have 2 and what here? And 9. Now, how do you manipulate these two numbers to give us this? And what? And this. Now, when you multiply them, you have what? Minus 18x squared. But when you add or subtract, we have what? 7x. Looking at addition or subtraction, what do we do? We can subtract, Abi. To subtract 9 minus 2, what we have? 7. Then logically, here will be what? Minus 2x, Abi. What will be here? Plus 9x. So 9x minus 2x is what? 7x. But 9x times minus 2 is what? Minus 18x squared. Is that okay now? So the two factors are what? Somebody? Minus 2x and what? And 9x. So we can say therefore, here we have 3x squared. Let's replace here. We have it to be what? Plus 9x. Are you seeing what I'm doing here? Minus what here? 2x. What do you have here? Minus 6 equals to what? 0. 9x minus 2x is what? Somebody? 7x. 9x times minus 2x is what? Minus 18x squared. Is that okay? So what is common between these two 10 and 7 10? 3x is common. In brackets, when you divide 3x squared, divide 3x squared by 3x. What's remaining here? Is x. So what be here? X. Divide 9x with this, with what? 3x. Divide 9x with what? 3x. X cancel x, Abi. 3 here, 1, 3x what? So what be here? Plus 3. Are you following somebody? Between this now and this, what do you think is common? Minus 2, Abi. They both have minus, minus. I can also generate 2 here and 2 here, right? So minus 2 is common. In brackets. Divide minus 2x with minus 2, what do you have? X. Divide minus 6 with what? Minus 2, what do you have? Plus 3. Equals to what? 0. I've already said it. Once you can get what is common here, anything you have with this bracket, just do what here? Repeat the same thing here. Are you following? Now let's go. Therefore, what do you have here? 3x minus 2 equals to what? 0. Or x plus what? 3 equals to what? 0. Are you following? How do you solve for x here? Here we have 3x. When you move minus 2 across the equal sign, becomes what? Plus 2. So 3x equals to what here? 2. Or when you move this 3 across, becomes what? Minus 3. So what do you have? x equals to what? Minus 3. Can we further solve for x here? Yes. What do we do here? Divide both sides by what? By 3. That means by 3, right? Let me just write. Just put by 3 here. By what here? 3. Can 3 go with 3 here? That means what here? X is equal to what? 2 over 3, or x is equal to what? Minus 3. But we are told that x is such that x is an element of what? Integer. Are you following? So what will be the value of x here? Minus 3. 2 over 3 is not an integer. It's a rational what? Number. Rational what? Number. Are you following now? That means that since x, correct me here. So what do you have here? Since x is an element of what? Z. Therefore, a is equal to what? Someone, let's go. What will be the answer here? Minus 3. Final what here? Answer. Is that C? Oh, sorry, C, not A. C is equal to what? Minus 3. C equals to what? Minus 3.